Hello, sir. My name is Manisha Gaur. Today we are going to explore a highly practical and fundamental concept of mathematics from class 12, that is matrices. So before jumping into the definitions and formulas, let's understand why we need matrices. We need matrices to handle, organize, and solve massive amount of um, interconnected data. This is the definition. Not getting? Let's understand it with a daily life practical example. You capture a photo on your laptop or phone. You know that the picture is made of small dot particles that are called pixels. Okay, pixels are arranged in some rows and columns, and your phone or computer stores your pixels in matrices form. Whenever you give a command to your phone to change in pictures like for cropping or change the filter, your in back inside your computer put the mathematical operations on matrices. It can be whether in rows or columns. Okay, let's take one another simple example. We suppose we express the information about Radha. That Radha has 15 notebooks. We may express it as with the understanding that the number written inside the bracket is showing the number of notebooks that Radha has. If we suppose one another condition that Radha has 15 notebooks and 6 pens, how will we express it? 15, 6 in horizontal lines. You can express it is in vertical lines also, 15 and 6, with the understanding that the first number is written inside the bracket is showing number of notebooks, and the second numbers inside the bracket is showing number of notebooks. Same is there also. If we talk about more than one or two persons, suppose we have three friends, Radha, Sham, and Simran. Okay. So Radha has note the three friends has notebooks and pens. Radha has 15 notebooks, 6 pens. Sham has 10 notebooks and 7 pens. Simran has 5 notebooks and 3 pens. Okay. So if we convert this information in tabular form, how will you express it? 15, 6, 10, 7, 5, 3. Okay. You can show this information in this form also. 15, 10, 5, 6, 7, 3. Both of this format you can use anyone. Okay. Here now, the horizontal lines are called uh, rows and the vertical lines are called columns. That means this is our first row, this is second row, and this is third row. Okay, and the vertical lines are called columns. This is our first column and this is the second column. Similarly, if we talk here, this is the first row and this is the second. And this is the first column, this is the second column, and this is the third column. Okay, so what is the difference between the things? You have to specify the uh, rows and columns. That here the rows are showing the three friends. First row is Radha, second row is Sham, and third row is showing the information of Simran. Okay. Similarly, the first column is showing the information about the number of notebooks, and second column is about the pens. Similarly, here the first row is showing the information about first column is showing the information about Radha, second column for Shyam, and third column for Simran. Similarly, first row for notebooks and second row is for pens. Okay. Now we can, after seeing this arrangement, tabular arrangement, we can give a definition of matrix. So what would be the definition? If you write the definition, a matrix is an ordered rectangular array of numbers. Not getting, this is your book's definition. Okay, let's understand it in a simple way. If you have a massive kind of data, and if you arrange your data in a tabular form, in rows and columns form, that particular form is called your matrix. Okay, that's enough to understand. Okay, now talk about the numbers. The numbers written inside it, inside the bracket or inside it, are called entries or elements. Okay, you always will denote a matrix with a capital letter. Always will not use small letters. Okay, let's take some another example of matrix. A minus 2, 1 by 2 under root 3.5. B sin x, x plus 2 cos x, 2 by 7. C 3 by 2, 0, minus 1, 2, 7, root 2. These are the three matrices. Okay. As earlier I have told you that the horizontal lines are represented by a row and the vertical lines are columns. So here in A, two rows, two columns. In B, same, two rows, two columns. In C, there are two rows, three columns. Okay. So let's introduce one another term in matrix, that is order of a matrix. Now what is it? Take a matrix in which we have m rows and n columns. Clear? Then the order of this matrix would be m cross n. And if we talk about the number of elements in it, equal to mn, would be equal to the multiplication of rows and columns. Okay, let's refer this concept in our examples. If we find the order of matrix A, here two rows, two columns, it would be 2 into 2, 2 cross 2. B, 2 cross 2, same. And matrix C, it would be 2 cross 3. You always write number of rows first in order. You can't write it n cross n. It will be always m cross n. Okay. Now, if we convert our m cross n matrix in tabular form, then how we will convert it? Suppose the matrix is A. Okay. So our first element, suppose A11, A12. Why 1? Because we are representing first row and first column. That's why 1, 1. A12, A13. Suppose middle term A1J. Row will be the first. No, the column will be changed. That's why we assume it J. And last element, suppose it is 1N. Okay. Suppose second row A21, A22, A23, A2J, A2N. Okay. Now assume a middle row. Suppose it is I. So how we will write it? AI1, AI2, AI3, AIJ. The middle element would be AIJ. Here is AIN. Okay. If we talk about last row, AM1, AM2, AM3, AMJ, or AMN. Okay. So here are, if we talk about the order of this matrix, it would be M cross N. Okay. So in general form, if we write it, how we will write it? A, AIG. We introduce the elements as AIG with the order of M cross N. Now, what are I and J? Here, we talk about the I shows number of rows. Now, if we talk the values of I, so then number of rows is starting from 1. So you will write here 1. And our highest number of rows are M. So you will write M. That means the number of rows will vary between 1 and M. Okay. Similarly, if we talk about J showing number of columns, the minimum value of J is 1 and the highest value is J is N. Okay, here I and J will always belongs to N. It will be natural number always. Okay, here one more thing I want to uh, explain you that 1 1, 2 1, 3 1. What are these things? 1 means M1 N1. Okay, here M2 N2, M3 N3. That means the elements is on the place where number of row is 1 and number of column is 1. So 1 1 means first row, first column's element. 2 1 is second row and first column's element. And A3 1 is third rows and first column's element. Let's take an example of it. Suppose we have a matrix A where our elements 2, 3, 5, 7, 2, 1, minus 2, 1. What is the order of it? Its order is 2 cross 3. Now, the question is convert it into 3 cross 2 order and find the values of A21 and A1. Okay. So firstly we will convert it. So for here are 2 rows, 3 columns. We will convert in 3 rows and 2 columns. So then how we will write it? We will convert rows into columns. 2, 3, 5, 7, minus 2, 1. Now the order would be 3 cross 2. To change the order, we will convert the rows into columns and columns into rows. That's it. Okay. Now about the elements A21, that means second row and first column. Now look at the table. Second row. This is our second row and first column. This is our first column. Second row, first column. So here the element is 3. Answer is 3. If we talk about A12, that means first row and second column. First row, second column. That means this is our first row and this is the second column. First row, second column, the element is 7. Okay. So this is our matrix. Now let's take another topic, that is types of matrix. We are having so many types of matrix. Let's start first column matrix. Then what are the column matrix? As the name the word is saying, it has one column. Examples: 0, minus 1 by 2, 3. The order is 3 cross 1. Okay, if you write it in general form, how will you write it? A. The elements suppose are in the form of Aij. Here the order would be M cross 1. The columns will always be 1. Okay, now talk about the rows column. Sorry, rows matrix. In which we have only one row. So example, minus 1, 2, 3, 7. So then order would be 1 cross 4. How will you write in general form? Aij. Here in order, the value of M should be 1 always. Okay, so it will be 1 cross N. Sorry, 1 cross N. Our next type, square matrix. Number of columns is equal to number of rows. Suppose the examples are 1, 2, 3, 4. So the matrix is 2 by 2. And if we take another example, B, 0, 1, 3, minus 2, 5, 7, 3, 1 by 2, 1. This is the order is 3 cross 2. In this, the number of rows and columns are same. If you write in general form, so Aij is equal to M cross M. Here M, the values would be the same. Okay. We can say that the order of this matrix is 2 or 3. You can say that the order of this matrix is M here. Okay. Our next type is for diagonal matrix. In diagonal matrix, we take square matrix, a square matrix in which non-diagonal element equal to 0. Let's take example. A is equal to 1, 1, sorry, minus 1, 0, 0. You can take 1 also, 2 by 2. The matrix should be the square matrix. The rows and columns will be same. Here, minus 3, 2, 1, 0, 0, 0, 0, 0, 0. The non-diagonal elements are here. These are the non-diagonal elements. So how, in general form, how will you write it? Here, Aij, M cross N. Here, the value of Aij would be 0 if I is not equal to J. Okay, there will be the condition with it. Similarly, our fifth type is scalar matrix. Then what is a scalar matrix? In which we take a diagonal matrix in which the diagonal elements are same. Okay, so take an example. It can take 2, 2, 0, 0, B, 3, 3, 3, 0, 0, 0, 0, 0, 0. It's 3 here. 2 cross 2, or this is 3 cross 3. In general form, you will write it is Aij, M cross N. Here the value of Aij would be 0 or any constant you can take, in which for 0, I will not equal to J, and for K, I is equal to J. K is any constant. Okay, so this is about Aij's value. Our next type is identity matrix. In identity matrix, a square matrix we will take, in which the diagonal elements is will be 1. So 1, 1, 1, 0, 0, 0, 0, 0, 0. This is our identity elements. The diagonal elements would be 1. You can say that our identity matrix is always a scalar matrix. An identity matrix is always a scalar matrix. Okay. Our last type is zero matrix. It's a very simple type. All elements are 0, equal to 0. Example. Okay, its general form we have not written. Aij, M cross M. Here the values of Aij, 0 for non-diagonals and 1 for I is equal to J. Okay, here if we take examples, so all elements would be 0, 0, 0, 0. Okay, so 2 cross 2, 3 cross 3. So these are the types of matrices. Now, thank you, sir, for giving me this your time and your the opportunity. I'm bringing up this structure and this approaches to this students of the Shirley International. Thank you so much.